Bem-vindos ao nosso espaço, um mergulho profundo nos assuntos mais interessantes de esportes, ciências e temas gerais do momento. Aqui você vai encontrar conteúdo de qualidade, com análises empolgantes e descobertas fascinantes que vão expandir seus horizontes. Nossa missão é trazer informação relevante de forma dinâmica e descontraída. Queremos que você faça parte dessa jornada incrível de conhecimento e diversão. Se gostar do nosso conteúdo, não esqueça de deixar seu like e se inscrever no canal para não perder nenhuma novidade. Ative o sininho também. Aproveite!
If you love science, don't forget to like and subscribe. Deep in the scorching plains of the African savanna, where temperatures can swing wildly from blistering triple digits during the day to chilling lows at night, one of nature's most sophisticated engineers is hard at work. We aren't talking about humans with high-tech blueprints and steel girders, but millions of tiny, blind insects, termites. For decades, biologists and architects have been fascinated by a seemingly impossible feat of engineering. How do these small creatures maintain a perfectly steady internal temperature inside their towering mud mounds, even when the external environment is hostile? The answer to this question didn't just change our understanding of entomology, it revolutionized the way we design our own urban landscapes. To understand the magnitude of the termites' achievement, we first have to look at the massive energy problem in human architecture. In modern cities, skyscrapers are essentially giant glass boxes that trap heat. To make them livable, we rely on massive HVAC systems that consume nearly 40% of a building's total energy. This creates a vicious cycle. The more we cool our buildings, the more electricity we use, contributing to the very global warming that makes our cities hotter. But termites solved this problem millions of years ago using nothing but mud, saliva, and the laws of physics. The Macrotermes michelsoni species builds mounds that can reach up to 30 feet high. Inside, they house a complex fungus that they cultivate for food. This fungus is incredibly sensitive. If the temperature fluctuates by more than a few degrees, it will die, and the colony will starve. To prevent this, termites have developed what scientists call the chimney effect, or passive ventilation. The mound is not a solid block of dirt, it is a living radiator. It consists of a network of tiny tunnels and a large central chimney. The termites use the heat generated by their own bodies and the metabolic heat from the fungus garden to create an upward draft. As the warm air rises and escapes through the porous top of the mound, it pulls cooler, denser air in through the base. Furthermore, the termites utilize the concept of thermal mass. The thick walls of the mound are constructed from a specific mixture of clay and sand that absorbs the sun's heat during the day. This prevents the interior from overheating. At night, as the savanna cools down, the heat stored in the walls begins to radiate inward, keeping the colony warm. It is a perfectly balanced, zero-electricity thermostat. In the early 1990s, an architect named Mick Pierce was tasked with designing a shopping mall and office complex in Harare, Zimbabwe. The challenge was immense. Create a large-scale building in a hot climate without using any conventional air conditioning. Conventional systems were too expensive to install and maintain. Recalling the structures of the termite mounds he had seen, Pierce decided to apply biomimicry to the project. This led to the creation of the Eastgate Centre, a landmark in sustainable architecture. The Eastgate Centre functions exactly like a termite mound. Instead of using fans and compressors to chill the air, the building uses a series of high-volume fans that move air through the building's core. During the day, the concrete structure of the building, its thermal mass, absorbs the heat from the sun and the people inside. At night, when the outside air is cool, the fans work at high speed to flush the warm air out of the building through 48 brick chimneys on the roof, replacing it with fresh, cool air. By the time the office workers arrive in the morning, the building is naturally chilled and ready to start the cycle again. The results were staggering. The Eastgate Centre uses about 10% of the energy of a conventional building of its size. Not only did this save the developers millions in energy costs, but it also resulted in much lower rents for the tenants, as the savings were passed down. This proved that we don't need to fight nature to be comfortable, we simply need to understand it better. Today, the lessons from the termite radiator are being applied to new structures around the world, from greenhousing in Sweden to sustainable skyscrapers in Singapore. As we face the challenges of a warming planet, these tiny insects offer us a blueprint for survival. They remind us that the most advanced technology isn't always something we invent in a lab. Sometimes, it's something that has been under our feet for millions of years. By mimicking the genius of insect architecture, we can create cities that breathe, cool themselves, and exist in harmony with the environment. For more incredible facts like this, don't forget to subscribe and turn on notifications.